Let's go to screen. And let's pull up what I've got for this started today. Today's the 30th. Today we're going to start looking at functions. It's going to take us into linear functions, which is going to take us into the idea of solving systems of equations. Exam 2 needs to be done by, does everybody see this? Saturday, end of the day Saturday. When is it going to be due by? 11:59 Saturday. Does everybody see that Saturday? If I said Saturday enough.
Yep.
Yeah.
Make
I
sure
just
you,
wanted to let you know I got your email about when I told you my power was out.
yeah.
I don't know if that set thing was due yesterday, but I didn't get to do that because my power was out for like 4 hours yesterday.
Okay, when you get it done, if you haven't, if it gives you a late penalty, send me an email and I'll take it away.
Okay.
Because I've noticed that when things like that happen and something comes up that somebody just for reasons beyond their control can't finish the homework on time, I find it's easier for both them and me if I just tell them, finish it as soon as you can. And when you finish it, I'll take away the late penalty. Because otherwise I have to draw a line in the sand and say, okay, I'll push the due date back one day. And then if you don't get it done within that one day, you're asking me to change it again. And it's just easier to say, okay, I realize it was beyond your control. Let me know when you got it done and I'll adjust. Okay. And that applies to everybody, anybody in class. If you know, like there was an accident or a power outage or, you know, a sick kid or something, you got called into work last minute and you don't get the homework done on time, just let me know. I can adjust that late penalty. But I know that if that due date is not there and that late penalty is not there, people just don't do their homework. So, when you take the test, you must submit your work in Blackboard. Remember, in order to submit your work in Blackboard, you have to be in Chrome or Firefox, or if you have an iProduct, you have to use an app. If there's anything that makes you think it didn't submit correctly, please, 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 please email it to me. But please try submitting it in Blackboard first, because honestly, it's easier for me to grade them if they're in Blackboard. And if they're in Blackboard and I grade them, you can see what I wrote on your paper. If you send it to me in an email, depending on the format that you send it in, some that get emailed to me, I am not capable to write on, and so I'm not capable to return your paper to you. Also, just a heads up, my next Monday, my office hour at 9 o'clock, I am going to be unable to attend. I'm canceling that office hour, and just for that day, I'm rescheduling it for 2 o'clock in the afternoon. So, having been through all of that, does anybody have questions on anything from that last section that we looked at, which basically was involved solving an awful lot of equations. And in order to enable us to solve those equations and inequalities, we had to talk about absolute value. We had to talk about computing the square. We had to talk about complex numbers, imaginary numbers, because there are some equations that don't have a solution unless we broaden our horizons to those complex numbers. And with solving inequalities, we also had to talk about that interval notation. Does anybody have questions on any of those? Anything from any of the back homework, anything from any of the back notes?
No, I'm good.
Good. Well, hopefully everybody else is good too. Thank you for responding and letting me know. If not, today we're going to start looking at something that's called a function. I'm guessing that some of you have heard of and worked with functions and function notation before, but I'm also guessing that this might be brand new for other ones of you. So I'm going to present it as new material. Again, if you're real familiar with them, I hope I'm not boring you to death and I apologize. But because I know that for some people, this is, you know, the first they've heard of it, I want to spend a little bit of time. Before I look at a function, I need to know what a relation is. And we're going to see that a relation is a set of ordered pairs. When When I look at ordered pairs, sometimes people think of them as ordered pairs XY. I think when we talked about graphing, we said that that X value is sometimes called the abscissa. The Y value is sometimes called the ordinate. When I look at relations, sometimes they're numeric, but sometimes they're not. If I look at a non-numeric relation, it could be something like a class roster. And on a class roster, for each and every one of you, I have a pair of information. I have your last name, and I have your first name. Leaving a space intentionally. I could be, does anybody ever, you go to the doctor's office and they might take information from you. They might look at your height and compare it to your weight. And for everybody, every patient, they'd have this relation, this list of ordered pairs, height and weight. We're going to look more at numeric relations. So let's say I have a set S, and it's got the ordered pairs 1, 1, 2, 2, 4, 3, 9, -1, 1, -2, 4. Again, I'm leaving spaces between them because I'm going to go back and fill them in. When we talk about a relation, we talk about something that's called the domain. And the domain is the set of first members of each ordered pair. Some people like to think of them as the X values or the abscissas. The domain is sometimes abbreviated with D. We also look at what's called the range. And I'm guessing that you can probably predict what the range is. The range is the set of the second members of each ordered pair. So that would be like the Y values or the ordinance. And a range would be represented by the uppercase R. Now, little memory aids helped me a lot. And so a memory aid, when I look at ordered pairs, when I look at them as coordinates, I was that stupid kid that couldn't remember which went first, the X or the Y, and somebody hit me over the head and said they're in alphabetical order. X is first, Y is second, because they're in alphabetical order. So if I take that idea of putting them in alphabetical order, that helped me remember that the abscissa is the first and the ordinate is the second. I'm putting them in alphabetical order. And in the same way, if I put those two words, domain and range, in alphabetical order, it helps me remember that domain comes before range, X comes before Y, so the domain is the set of X values. and the range is the set of y values. Does that make sense?
Yes.
Those of you who are going from here into the advanced algebra and trig class, you're going to find that, again, the idea of coordinates is related to your trig functions. And so that idea of putting them in alphabetical order helps remember that relationship too. But I want to go back to these examples of relations that I had before. And so for the class roster, my domain, or D, would be the set of last names. And my range, or R, would be the set of first names. At the doctor's office, if my data was paired the way it is now, the domain would be the set of heights. And the range would be the set of weights. This next one, I want to introduce a little bit different notation. The domain will use D. Is everybody all right? I'm going to put a subscripted S. And that subscripted S means I'm looking for the domain of the relationship S. And so here, if I asked you, what's the set of first members? If I were to list them, what would be in that set? 1,
2, 3, -1, and -2.
beautiful. And so when I look at for the range of S, I would refer to that as R sub S, the range of S. And now if I look at the Y values, what do I have?
Would be 1, 4, 9, and 1.
1, 4, 9, and 1 and 4. But you know what? When I list a set, I don't repeat values. One's in that set already. So when
Okay.
you set, but I get exactly what you mean. You do not repeat values.
Let's go potty.
Everybody all right with those definitions so far?
Yeah.
Great. Then I'm going to turn the page and we're going to graduate from relations to something that's called a function. And we're going to say a function is a relation. And so we're saying that a function is a set of ordered pairs, but it's got a special criteria that's set. It's a relation in which member of the domain and each member of the domain is each first member. It's like each X value is paired with one and only one member of the range. So each X value has only one distinct Y value. I know some people look at it as if we're saying that the X values cannot repeat. And so let's look at some examples. Let's look at that set S that we just had before on the other page, but I'm going to rewrite it because it's on the other page. 1, 1, 2, 4, -3, -9, -1, -1, -2, 4. And I'm going to ask, is this a function? As I look at those ordered pairs, does each x value have only one y value? X value of 1, it only shows up there. X value of 2, it only shows up there. X value of 3, it only shows up there. X value of -1, only used once. X value of -2 is only used once. So, is it a function? Yes. Each member of the domain appears only once. Let's look at another example. Let's look at a set T. In T, I'm going to have 1, 3, the pair 2, 4, the pair 3, 5, the pair 4, 6. I want to know what the domain of T is. I want to know what the range of T is. And I want to know, is it a function? Now, is there anybody who's brave that wants to list for me the domain of this set? Tell me what all the first values are.
The domain would be 1, 2, 3, and 4.
And how about the range?
Would be 3, 4, 5, and 6.
And
It is a function.
it is a function, great, because each x value is used only once. Now I want to look at another example. Let's have V be the set of ordered pairs 5, 2, 6, and 7, 2. I want the domain of V. I want the range of V. And I want to know, is it a function? So what are my x values?
It's 5, 6, and 7, and then the range would only be 2.
And now, is it a function?
No, it's not a function because 2 repeats itself.
2 repeats itself, but that 2 that repeats itself, it's a y value, isn't it? In order to decide if it's a function or not, I'm just looking at the x values. And if I look at the x values, do any of the x values repeat?
No.
No. So this is a function. In order to be a function, x's cannot repeat. It's okay if y's repeat, but
Okay.
x's cannot repeat.
Okay.
Okay?
Mhm.
Now let's look at another one. Let's look at U. And let's say U is the set of ordered pairs 1, 2, 2, 4, and 1, 3.
So the domain would be 1 and 2,
Mm-hmm.
and then the range would be 2, 4, and 3.
And now when I ask myself, is this a function? I'm going back and I'm just looking at the first members. Do any of the first members repeat?
Yeah, 1 does.
1 does. So the answer here is no, it's not a function. 1 is used more than once. 1 is paired with 2. 1 is paired with 3. So when I look at that number 1 for my domain, it doesn't have a single member of the range. It's got 2 different ones. All right? Sometimes it reminds me, and this is really bad, sexist, back in the day in Utah when there was polygamy, it was okay for man to have many wives, but it wasn't okay for a woman to have many husbands. And so it's okay if Y repeats, it's not okay if X repeats. Kind of like it only works one way. So anyways, that's it. When I look at a function, sometimes we can have a relation and or a function given by an equation. If it's given by an equation, the x, which is from the domain, is called the independent variable. And the y, which is from the range, is called the dependent variable. And it's, you know, it's because usually you pick x, you can pick any number that you want for x, and you put it in the equation to find y. So x, usually the choice of x can be any number, and y is what you get when you substitute that value in for x. And so let's look at an example. Let's say I have an equation x plus y equals 7. And I want to know, is it a function? And in order to make that determination, sometimes it's easier if I solve for y, pardon me, in terms of x. So if I try to get that y alone, does everybody see I'd have y equals negative x plus 7? And so now for any given x value, wouldn't I only get one y value? And so I'd say that, yes, it is a function. Instead, if I have something like x squared plus y equals 25, when I go through and solve for y, I would get y is equal to 25 minus x squared. And no matter what I put in for x, wouldn't each x value only give one y value? And so it is a function. Instead, what if I had something like x squared plus y squared equals 49? If I were to try to solve this for y, I get y squared is equal to 49 minus x squared. And then to solve this for y, wouldn't I take the square root of both sides?
Mm-hmm.
And wouldn't I get over here, thinking about what we did with that square root problem, wouldn't I have two roots, a positive and a negative one? And so if I have two roots, a positive and a negative one, doesn't that tell me that there are two y values for each x value? And so this one is not a function. Everybody all right with that?
Yes.
All right.
Can you
Well-
hold that for a minute?
Sure.
Thank you.
And I need another sip of coffee, so this is great. Thank you for giving me a coffee break.
You're welcome. I'm all done now.
Okay. So in addition to looking at a function or a relation as an equation, sometimes we look at the graph of a relation or a function. And in order to find the graph of a relation or function, we're going to see its set of points whose coordinates are in the function, are in the relation.
Stop, Winston, please.
And I have to apologize, you guys. I just need to take 1 second. I'll be right back. It's not coming till tomorrow if you want to wait. The delivery company.
We want to.
Yeah, they're coming tomorrow afternoon. I think today's probably easier for Amy then. So sorry about that, folks. A little bit of family business going on. All right, so let's look at an example. I'm going to be a little bit lazy. And so for my first example, I'm going to look at that set D that we had, which was 5, 2, 6, 2, 7, 2. I want to graph that. And I also want to look at that set U that we had, which was 1, 2, 2, 4, 1, 3. And I want to look at that graph. So with the first one, if I plot those points, I've got the point 5, 2, 6, 2, 7, 2. And looking at where those points fall, is it obvious that for each X value, I only have a single Y value? As opposed to this next one, when I go to graph that, labeling my axes X, Y, my X values are only 1 and 2. My Y values go up to 4. So I have the point 1, 2, 2, 4. And also I have the point 1, 3. And as I look at this graph, if this were on a graph paper grid, would it be obvious that those 2 points lie on the same X value 1?
Yeah.
And that gives us, if we've got a picture in front of us, an easy way of determining whether something is a function or not. And it's called the vertical line test. And what the vertical line test says is a graph is a function if any given vertical line intersects it in at most one point. And so if I look at that graph that we have here, do you see this vertical line hits it twice? So this we could say fails the vertical line test. And so some really rough sketches here. There's going to be some on the homework, but the sketches aren't quite as rough as mine. But let's say these are my axes, X, Y. And let's say my graph is a line. Does everybody see that if I started drawing all of these vertical lines, any vertical line would only intersect it in a single point? So this would be a function. It passes the vertical line test. Instead of a line, let's say I have a curve of this shape, which we'll refer to later as a parabola. Would this pass the vertical line test? I start drawing all these little vertical lines in there. If I picture taking a pencil lead and rolling it across the graph, at any given spot, it would only hit it in one point. So it passes the test, and it is a function. Instead, let's say we've got an equation that we'll graph later in the semester, and it gives me a circle. As I look at the circle, do you see over here, that vertical line would intersect it in 2 points? So it fails the vertical line test. So it's not a function. And one more. Let's say I have a parabola that opens sideways. Looking at that graph, would it pass or would it fail my vertical line test?
Oh, it would fail, wouldn't it?
Yeah, if I drew a vertical line here, it would most definitely fail. And so it's not a function. Sometimes, and I have to apologize, I'm not a good drawer. So for these next couple, I'm going to take a second and open that virtual textbook and look at some of the questions from the book. So just be patient with me for a minute. I'm sorry, I didn't have this open before, but my last class the reason I was late with starting class was because people had questions and hung around to the end of the class. I'm going into the textbook. Have any of you used the virtual textbook?
Not yet, I haven't.
No, did y'all see where it is? If you ever want to read through something in the textbook, well, you think you just bought that access code instead of a book. That access code comes with an ebook. So,
Yeah, I know where it is. I just haven't used it yet.
and now, of course, it's taking a very long time. And I'm just thinking if I wanted to go to the homework problems, I should have scooched to the end of the section and not the beginning. So. Let's see if I can in my actual book. If it's the right edition. It isn't. I'm so sorry, you guys. Actually, let's look at these graphs here. And what I want to look at is a couple of things. I want to look at, for each of these graphs, is it a function? The questions that are written here asks you to find a function value, but I also want to try to find the domain and range for each. So let's look first at this question, number 87. First question I want to know is it a function? Would this pass or fail my vertical line test?
Wouldn't it pass?
Yep, so the answer is yes, beautiful. Now, what's the domain? I'm looking,
Domain.
it's got an arrowhead to the
All
left.
real numbers?
Yeah, isn't it all real numbers? Because it doesn't stop going in either direction. Interval notation, we'd say that's from negative infinity to infinity. What's the range? If I look at that going up and down, does that take on all y values? Or
Would
is
it
it
only be negative values?
only negative values? But do you see how, looking at it, the largest value is -2, and it can equal -2.
Okay.
There's no smallest value. If I look at number 89, is 89 a function?
Yes.
Yes. If I look at the domain, is there a smallest x value or a largest x value, or does it keep on going in both directions?
It's going both directions.
So that would be negative infinity to infinity. If I look at the range, is there a smallest y value or a largest y value?
No.
Well, you see how this is going down, and then over here it says the graph approaches but never touches
Oh.
the axis. So
Oh, yeah.
that smallest y value is 0, But
Okay.
because it doesn't touch it, it's going to be open on that side. And there's no largest, so it goes on to infinity. And if I look down here at number 91, where the function is just those points, it is a function. If I look for the domain, what would you tell me the x values are of those points? This first one is,
Would be negative infinity to,
I'm just looking at these single points. So don't I have an x value of -5, an x
Yeah.
value of -2, 0, 1,
and
and 3. And what's the range? What's the y values of those points? Don't they all have the same y value, which is 2?
oh yeah, they do. Yeah.
And then for 88, I don't want to answer my random questions, but I just want to answer the question that they ask. This one asks for me to find f of -2. And so to find f of negative, oh, you know what, take that back. We'll come back to this problem in a minute. We didn't look at function notation yet, I apologize. So we'll be back to this one in a minute. Is everybody all right though with finding the domain and range from the picture? There are some in the homework that ask you to do that. If so, I'm going to clear this, but I am going to leave this page open because I want to come back. And I want to look at next what we call function notation. And when I look at function notation, what happens is sometimes we name a function. Sometimes it's with a letter, sometimes it's something else. So I could over here say that f is a function such that y equals 4x plus 5. And if this function is named f, you sometimes see notation f parentheses x, and we read this as f of x, and f of x is just a fancy way of writing y. So we'll say that f of x means y. And so where I had written f is the function where y equals 4x plus 5, we could rewrite it as f of x equals 4x plus 5. And so I want to look at one problem written two ways. Let's say we know that if y equals 4x plus 5, you might be asked to find y when x equals 1. And if I asked you to find y when x equals 1, what would you do? Put
Plug
everybody
in 1 for
sub-
x.
Yeah, beautiful, sub in 1 for x. And so we'd have y equals 4 times 1 plus 5, which would be 4 plus 5, or 9. So we'd be able to say that when x equals 1, y equals 9. And we could write that as a
That works,
there,
machine.
1, 9. Is everybody comfortable with that?
Yes.
Well, one of the reasons this function notation is kind of cool is because where I have y equals 4x plus 5, I could write that as f of x equals 4x plus 5. And this part over here where I'm asked to find y when x equals 1, I could write that as find f of 1. And when I write it this way, do you notice what I did was I replaced x with 1. And so that's telling me to find y when x equals 1. So I'm just going to put in 1 in place of the x, and that's going to give me that 9. And so down here, where I wrote when x equals 1, y equals 9, I could write that as f of 1 equals 9. What's in the parentheses is my x value, and what it equals, that f of 1, would be the corresponding y value. And so I should be able to look at this statement and see that that's also giving me that same 0.19. And so with function notation, if my function is f of x, to find a value or an expression, f of a, you substitute a for x. And so, for example, does everybody have all this? Can I go on and look at a couple examples, or do you guys want me to wait a minute?
I'm good. I don't know about anyone else.
If they're not speaking, we'll go with you. So let's say g of x is equal to 3x minus 6. We want to find g of negative 4. We want to find g of 5. We want to find g of 7. We want to find g of negative x. And we want to find g of x plus 2. So when I look at this function notation, if g of x equals 3x minus 6, I actually think of that as g of whatever I put in the blank is equal to 3 times that quantity minus 6. And so if g of x is 3 times x minus 6, g of negative 4, where I had an x, I'm going to put in negative 4. And so working that out, let's see, negative 12 minus 6 would be negative 18. If I want g of 5, this time I'm using that same rule, 3 times whatever goes in for x minus 6. Is everybody all right? This time I'm replacing x with 5. 3
Yes.
times 5 is 15, minus 6 would be 9. This next one, 3x minus 6, but this time we're replacing x with 7. And so 21 minus 6 would give me 15. Next one's interesting, g of negative x. Well, where I had an x, I'm going to put not x, but negative x. Order of operations, I multiply first, just like I did with all of the preceding. 3 times negative x would be negative 3x minus 6, and I'd have to stop with that expression. And in the next one, g of x is 3 times x minus 6. But instead of just having an x in there, I have an x plus 2. The way this one is written, does everybody see the need to distribute? 3x plus 6 minus 6. And so here I just have the expression 3x. And this function notation with this idea of substitution, is that familiar territory for you folks? Is that new stuff, or do we have some of each?
It's not new. It's
That new? All right, then let's have another example. F of x equals x squared plus 2x plus 3. And I'm going to be quiet for a minute and ask you folks to find f of negative 1, f of 3, and f of x plus 2. And with this last one, I want you to simplify. You guys want me to wait a minute longer? Are you still working, or are we done?
Still working.
Okay. Let me know when you're ready. Can we go over yet?
Go ahead.
Okay, for the first one, did everybody get 2? Negative
I
1
did.
squared. Beautiful. For the second one, did everybody get, when you plugged in 3, 3 squared plus 2 times 3 plus 3 should give you 18.
Mm-hmm.
Yeah.
Next one, when I plug in x plus 2, I'm taking x plus 2 quantity squared plus 2 times x plus 2 plus 3. And when I did that, I got x squared plus 6x plus 11. Did everybody get that, or do we need to add a little bit of detail to this one?
I'm good.
I'm good.
Okay, so function notation, life is good. With function notation, one thing that I want to make sure we mention, although I believe we've already mentioned this semester, we said that in a function, if the domain is not specified, it will be all real numbers for which it is defined. And so to find the domain of a function, if it's not specified, most things are defined, most things have meaning. What we have to watch for is there are two things that can be undefined with real numbers. And the first that we've talked about somewhat is a 0 in the denominator. For example, if I have g of x equals 2 over x plus 7, and I'm not given a domain, if I look for the domain of g, well, it's a fraction. So I'm worried about what values give me a 0 in the denominator, and that's -7. So I could say that it's all real numbers except -7. So I could say the set of all x such that x does not equal -7. Or I could put that in interval notation. I can take every number, negative number up until -7, and combine it with every number larger than -7. And again, if I'm focusing on reals, the other thing I have to worry about is if I have a radical with an even index,
Either's fine.
think square root,
I'll grab the first.
the radicand must be not negative. And so what does that mean? If I have f of x equals the square root of x minus 7, to say that the radicand is non-negative means that what's underneath the square root, x minus 7, has to be greater than or equal to 0. So that gives me x is greater than or equal to 7. And so for the domain of f, could you guys mute if you're not answering the question, please? The domain of f would be the set of all x such that x is greater than or equal to 7, or in interval notation, the smallest value is 7, which it can equal, and I'm going to infinity. Now, for just a second, while we're still on function notation, I want to go back and look at that textbook. And on this textbook, page, they ask the real question. Could you mute, please? The function, to find the function value, okay, folks, give me a second. Oh, sorry. To find f of 2, that means is when x is 2, what's y? Can everybody read coordinates off a graph? When x is 2, it means I'm along this line. Does everybody see that when x is 2, the y value is 1? So I would say that f of 2 is equal to 1. Instead, with the one above it, they ask me to
This
find,
is Kyle Korzak. I'll give you a call in.
thank you. When they ask me to find f of 4, they're saying when x is 4 on my graph, what's my y value? And does everybody see here, f of 4 would be 6. Everybody all right with that?
Yeah, I get it.
Okay, great. Then let's clear that. And let's go back to where we were writing. And when I look at the graph of a function, something that we sometimes discuss are the intercepts. Somebody have a cat near their computer. Oh my heavens. The intercepts are where a graph crosses the axes. So I'm going to draw a set of axes. And if I talk about the x-intercept, the x-intercept has to be a point of the graph that's on the x-axis. And if I look at my x-axis, if I look at all of the points on the x-axis, you notice what they have in common is they all have a y value of 0. So to find the x-intercept of a function, or any relation actually, we'll substitute y equals 0 and solve for x. In the same way, the y-intercept is a point on the y-axis. That's also on the graph. And this time, if I look at all of the points on the y-axis, what they have in common is that their x value is 0. So to find the y-intercept,
What's up?
Why'd you ignore my call?
somebody
was
carrying
at
on a
Tim
phone
Hortons drive-thru.
in the middle of class.
Oh, why'd you go to Tim Hortons?
Let's go through,
Because Josh asked,
mute everybody.
Okay.
how you doing?
Just doing.
Okay, sorry about that, folks. Did I mute myself? Can you guys hear me?
Yeah, I can hear you.
Yeah.
Okay. All right. So to find the y-intercept, we substitute x equals 0 and solve for y. So how would that look on the homework? You might be given something like if 3x plus 4y equals 12, let's find the intercepts. And so for the x-intercept, again, we're going to substitute 0 for y. So when we do that, we get 3x plus 4 times 0 equals 12, which would give me 3x equals 12. So dividing, we get x equals 4. And so my x-intercept as a coordinate would be the point, apologize, when x is 4, y is 0. And in the same way, to find the y-intercept, we'll let x equal 0. We're still using that same relation, 3x plus 4y equals 12. But now when we're looking for the y-intercept, we put in the 0 for x, which gives me 4y equals 12. So dividing y, I get by 4, I get y equals 3. And so my y-intercept as a point would be the point x is 0, y is 3. So sometimes we'll find the intercepts by looking at the graph. And sometimes we'll find the y-intercepts if we're given an equation by just substituting in 0 for x if we're looking for the y-intercept, and substituting in 0 for y if we're looking for the x-intercept. Instead, if I'm looking at my graphs, let's use, none of those are very good. I'm turning the page for a minute. Is it gonna let me turn the page, or was it gone too long? Let's look at some of these. And over here in this question.
Hello?
I need to tell you that you're going to be a dad.
Oh, God.
Mute yourself. Sorry about that. If I look at this graph, does everybody see that here the y-intercept would be -3, and this one has 2 x-intercepts. The x-intercept, one would be the point -3, 0, and the other would be the point 1, 0. Instead, if I look at this graph, the y-intercept, where I cross the y-axis, would be the point 0, 1. And this one, if I ask for the x-intercept, does this graph cross my x-axis at all? No, so we'll say that there's none. Everybody all right with finding those intercepts from a graph, looking at it? Yeah, okay, great.
Can you go back to the notes real fast?
Yeah, I'm going, that's where I was going next. I just wanted to make sure that we looked at some of these and, oh my gosh, is it really 12:15 already?
Yes.
So I guess that'll be the last thing that we do today. We're stopping here. I'm making a big note on it for the 11 o'clock section. And so far, definition of relation, definition of a function, finding the domain and the range, using the vertical line test, function notation, and finding the intercepts. Are we okay so far?
Yeah. It was pretty much review.
Okay. All right. And again, I think it's review for some folks. I don't know, is this brand spanking new stuff for other folks or not?
It's
No,
review for the most part.
It's review for the most part. Am I going too slow or is this all right?
No, this is all right.
Good.
Okay, do you guys need the gentle nudge to your memories?
Yes.
Yeah.
Definitely.
Okay, all right. Then before I let you go, I'm only gonna ask the people who came in a little late to hang on so that I can make sure I made note of them being here, although I don't remember anybody adding anybody late. Is there anybody who came in late? If not, have a great weekend. Be careful on Halloween and make sure you do that test and submit your work before the end of the day. Saturday. If you do it by Saturday, I'll grade them on Sunday and you can see how you did on Monday. Have a good one, folks.
Professor,
Okay.
question.
Yeah.
What do I do? I just got a phone call saying I'm going to be a dad. What do I do? I need some serious life advice.
You take responsibility. I don't know. That's between you and the person who is going to be the mom. If you really are looking for some counseling type of advice, there are all sorts of counselors available at the college that you can talk to. If you really want to talk to a counselor about what the possibilities are, I would start at the wellness center and talk to
Okay.
someone there. Okay. Otherwise, I can give you something that aligns with my own personal morals, but I think that you need to instead just reflect on your own and make a decision based off of that. And I think a professional counselor would be better at helping you with that.
The problem is I don't even entirely know who she is.
Well, again, that's a reflection on your personal morals. You have to probably meet with the young lady and see if you recognize her at all and see where it goes from there.
Should I go to Maury and make sure it's mine?
I don't know what you mean by go to Maury.
Like get the paternity test on that TV show.
I wouldn't go there. So I would again talk to a counselor and maybe a doctor and the young lady involved and see where it goes from there.
Okay, thank you.
Okay. All right. I think the status of the country at this point in time, and this again is sharing some of my own beliefs. I think that the status of the country at this point in time shows us what goes wrong when we rely on reality TV stars for advice.
Mhm.
Okay.
Yeah.
All right. Have a
Thank
good
you.
one. Okay.
You too.
Bye.
Bye.
Anybody who's left have any questions? Have a good one. Bye-bye.